Now today we are going to see the second part of correlation and regression. These are our today's content, that is rank correlation, then Spearman's rank correlation coefficient. It is without ties and with ties. We see both the formula and one of the example for the without with ties example. Then regression line y on x and regression line x on y. And what are the applications of correlation and regression? So first, let's check out the terms used in rank correlation. We have already seen the Carl Pearson's rank correlation coefficient, right? Sorry, Carl Pearson's correlation coefficient, which is specifically used for quantitative data. But for the purpose of qualitative data, such as if there is a competition of singing competition or dancing competition, you are seen when, many times that in such competition or in such stage shows there are three judges which gives the ranks for the participants, and after the completion of all competition, the judges are comparing their ranks with each other, and after that they will declare the results. So which formula it is used to compare the judges ranks with the three-person, because they are just giving the rank as a first, second or third number as per their performance, but they are not scoring, they are not giving a score such as how much percentage it is, and there is no same platform for the purpose of their segregation. So for that qualitative data, such qualitative data, rank correlation is used. So first, we will see what is ranking. Ranking, it means ordered arrangement of atoms according to merit that they possess is called as ranking. Such as this first, second, and third rank. These are given for the performance. For example, first batsman, man of the match, right? Man of the match is किंवा man पूर्ण series मधलं man of the series असते. So these are the ranking which is possessed on some merits, and it is given as an order arrangement as per their benefits or merits what they possess. Then second one is rank. Rank, it means it is a number indicating the position in the ranking is called as a rank. So whatever position they have in a overall series, comparative series, the number indicates the rank of the particular atom. And the last one is tie. Tie, it means when there is a tie at a match when the score is same. Right? For example, there are two teams A and B, and both are scoring 100 and 100 runs. Then that time it is a tie. What the situation is there? Then the judge, what the umpire declared, umpire gave a one extra over of 6 balls, and said that it will be decided on the basis of this 6 runs. Sorry, 6 balls. That is 1 over. So with the help of that, they can go for the decision. But in case of ties in a competition, what is the solution? So tie, it means a tie is said to occur in ranking if two or more atoms have same merit. They have a same score, they have a same merit in the series, then it is called as a tie between these two or three or whatever atoms are there. There is a tie between these two or three atoms. In this case, we allot common rank to these atoms. You have often seen that when there is a ranking in the board examination, so that if there are 2% or 3% of the same rank, then the for second, third, and fourth, whatever rank they are bearing, it is skipped from that particular merit list, and the rank is given to the next person with the next number. Such as second number rank has a three numbers. Three students has the same marks for the second ranking. That time, second, third, and fourth, these three ranks are covered by these three students, and the next person will get the fifth number as a ranking score, and these three students get the same rank with the average of their marks. Okay, so in this case, we allot common rank to these atoms which has the same scoring or same merit, and it is an average of ranks which would have been allotted if the respective atoms would differ in merit slightly. This term can be more clear with the example when we see the example for that ties. Now, what is rank correlation coefficient? So the product movement correlation coefficient between these ranks is called as a Spearman's rank correlation coefficient. It is same as your Carl Pearson's correlation coefficient, but it is specifically used for the quantitative data, but rank correlation is used for the quantitative data. So it is denoted by capital R. Remember this one. If they ask you the formula for R, this R, capital R, that time you have to write the formula as it is. R is equal to 1 minus 6 summation of D square upon N into bracket N square minus 1. Now what do you mean? What do you mean by D? So D is the difference between corresponding ranks of X and Y for an individual observation. It means for the same person, and judges are giving the ranks. So difference between these two judges or three judges, whatever judges are there. So difference between these ranks for the same person by two or more person, it is called as a D. D is equal to rank of X minus rank of Y, and N is equal to number of pairs of observations. It means how many participants are there, or what are the how many pairs are observed by the judges, given the given judges for the competition or for any scoring criteria. Now Spearman's rank correlation coefficient. It is simple to compute and useful for qualitative data. So mostly it is used for qualitative data. However, there is a loss of accuracy whenever we compute it for quantitative data. It can be used for quantitative data also. So Spearman's rank correlation coefficient can be used for qualitative as well as quantitative data. But for the quantitative data, it may lose accuracy because there is a calculation depends on the rank basis. So there may be the difference between the quantities defined by the defined as accurately as by the Carl Pearson's formula. It can be used for quantitative data such as intelligence and mathematical aptitude, intelligence and anger and aggressiveness. So these are the qualities of person which are converted into quantitative data. Such as these are mostly used in psychological tests. So when there is an exam after 10th or 12th, after mostly used in the after 10th examination. After the 10th examination, when you want to focus on your career, there is a career counselors. Career counselors are doing the same thing, that they are measuring your intelligence and aptitude. Which type of aptitude do you have? Which area of interest do you prefer? And for that, on that basis, they prepare data, analyze that data, and on the analysis of that data, they consult the person that which side or which career path is good for that particular person. So it can be arranged. Such psychological test can be arranged through the Spearman's rank correlation coefficient, because even though it is in a quantitative data format, but these are the mostly focused on qualitative data, that is characteristics of a particular person. When smaller the difference is larger the correlation, and vice versa. If difference is smaller, the correlation value is larger, and if the difference is larger, then the correlation will be smaller. It may be negative also, less than 0 also. Spearman's rank correlation coefficient lies between -1 and 1. Same. It has a base of Carl Pearson's coefficient correlation. That's why it also lies between -1 and 1 only. Let's check out with the ties formula. So with ties, we just add this one Tx plus Ty. Tx means ties in X series plus ties in Y series. So what do you mean by Tx? So let's check out. Tx is equal to summation of M into bracket M square minus 1 upon 12. It is in ties in series X. And if it is a Y, then same summation of M into bracket M square minus 1 upon 12. Now what do you mean by M? So here M, it is the length of ties in the series. That is number of times repetition of rank. For example, there is a score of 20 marks, and 4 students are having a 20 marks in the same series. So length of the ties becomes 4 and number becomes 1. So one pair has a length of 4 ties. So it will be added as a one series in a one repetition. Okay. So let's check out with the example so that you can it will be more clear. So it is the sum given, the runs scored by 11 cricketers in 2 test matches, M1 and M2. So what these are the cricketers A, B, C, D, E, F, G, H, J, K, right? And there are runs scored in two matches. So M1 is first match score and M2 is second match score. So what they have said, compute correlation between runs scored by cricketers in the matches using Spearman's rank correlation and Carl Pearson's. So now here we just go for the Spearman's rank correlation coefficient, and Carl Pearson's formula can be check out through your book also. I have already shared the same in your classroom. So Spearman's rank correlation, for this we have to arrange the ranks. So here these ranks. So first one M1, M2. So suppose it's a X and it's a Y series. Okay. Now we have a number of pairs. This one A, B, C, D, right? These are your number of pairs. So N will be this count, cricketers count. What are the scores are there? 82, 82, 85, 35, 55, 33, 52, 73, 55, 50, 50. And for M2, these are the scores. So for X, we will allot the ranks. So while we allot the ranks, either you have to go from higher to lower or lower to higher. But it's better we'll go higher to lower. It will be easy to segregate. So in X series, let's check out what is the highest number. It's a 85, right? So we give this the first rank for the 85. The second rank, second number is 82, right? But 82, there are two numbers. There are two cricketers having a same score. So these are two numbers with the 82. So rank for these numbers was 2 and 3, right? If they are not equal, then the rank will be 2 and 3. So these two ranks are merged. So the rank for this two will be given as 2 plus 3 divided by 2, that is average of the rank. So 3 plus 2 is equal to 5, 5 divided by 2 is equal to 2.5. So we give the same rank to this 2, that is 2.5, 2.5. Okay. Now third one, now second and third rank is absorbed by these two numbers. Now the next one will be after 82, what is the smallest number? This is 73, right? Now second and third is absorbed by these numbers, so fourth number rank directly given to the next number. Now after 73, what is the smallest number? Sorry, highest number is a 55. So 55, this one and this one. There are 255. So what is the rank for this two? 4 we have covered. So 5 and 6. So 5 and 6, average of 5 and 6, 5 plus 6 divided by 2. So it becomes 5.5. So for these two numbers, we give the same rank 5.5, 5.5. The ranks which is absorbed by that particular rank numbers, it is take an average of these numbers, ranks, and divide so that this average will be considered for the rank. Now, after 55, what will be the next one? 55, then 52, right? So 5 and 6 are absorbed by these two numbers. So next will be 7 number. So 52 is given the 7th number. After 52, smallest is 50. This one, this two. 7 number is given. So next one will be 8. But there are two numbers. So 8 plus 9. 8th rank and 9th rank. Okay, and divide by 2. So it becomes 8.5. So these two persons given the same rank 8.5. So 8 and 9 is covered. The next rank will be 10. So what is the next number? It's a 35. So it's a 10 number. After 35, it's a 33. It's a 11. Obviously, the number of pairs should be matched with your rank. So these are the 11 numbers. So ultimately, last rank will be 11 only. Okay, is it clear? We'll again see in a Y series also. So it will be more clear. In Y series, now what is the highest score? It's a 93. It's a first rank. The next one is 87, right? This is, so it's the second number. After 87, what is the smallest number? Sorry, highest number is a 65. Sorry, 66. So 66 is a third number. 65, 4, 64, it's a 5. 62, it's a 6 number. Then the next one is 50 number, right? So for 50, there are three numbers. 50 is ranking with the three numbers. So what are the three? This 50, right? This one, and this one. It means 50 number repeated thrice. So last rank was 6, and there are 3 ranks. Next 3 ranks are absorbed by this 50. So 7 plus 8 plus 9, right? 3 ranks are covered by the same number. So divide by, there are 3 numbers, so average divided by 3. So when we calculate this, we'll get this as a 7 plus 8 plus 9 and divided by 3. So it will be 8. So same rank will be given to this 3 number, that is 8, 8 and 8. It is called as a same rank number for the ties. So 8, 7, 8, 9, these ranks are absorbed. Next rank will be directly 10. So after 50, what is the smallest number? Second smallest number is 37, right? So 37 got the 10th rank. And the last one is 31, it got the 11th rank. It is called as a ranking. It is to be given as a ranking for the purpose of rank correlation. After that, we have to find out the d square. So d square, it will be the difference between ranks. So this one, first one, 2.5 minus 8 and that's a square, that is 30.25. Then again 2.5 minus 8, their square, 1 minus 1, 0, 0 the square, it is always 0. 10 minus 1 minus 1 minus 1 square is 1. 5.5 minus 3 square, that is 2.5 square is 6.25. Then 11 minus 10, 1. So 1 square is 1 only. 7 minus 2, 5. 5 square is 25. 4 minus 8 is 4. 4 square is 16. 5.5 minus 6, that is 0.5. So 0 point square is 0.25. 8.5 minus 5 is 3.5. So 3 point square is 12.25. 8.5 minus 4, it's a 4.5. So 4.5 square, 20.25. So we got this square. So for Spearman's rank correlation, we need a d square. That's why we calculate d square. Now there are ties of in X series also and Y series also. So for the first, we'll calculate the ties Tx and Ty. So here in series X, there are 3 ties. Right? 3 ties are there. One is for 82 number. There are 2 ties. For 55, there are 2 numbers, and for 50 also there are ties. And these are of length 2. All of these are length 2. So Tx is equal to summation of Tx is equal to summation of m square minus 1 upon 12. It means whatever ties you have found in the X series, you have to add. So there are 3 ties, so we have to add 3 numbers. So first one, for 82, there is length of 2. So 2 into bracket 2 square minus 1 upon 12 plus. For 55, it is also of 2 length, second length, so 2 square minus 1 upon 12. For 50 also, it's a 2 length of 2. So we'll add 2 into bracket 2 square minus 1 upon 12. When we calculate it, it will be 1.5. It's a TX series. Okay, for the series of X, we calculate ties. So there are 3 ties with the length of 2 each. So we just go for this calculation. Now for Y series, there is only 1 tie. Right? Only 50 number is repeated, but the length is 3. So for series Y, there is only 1 tie, that is 50 numbers, and it is of length 3. So we just use one formula only, that is m is equal to 3. 3 into 3 square minus 1 upon 12. When we simplified it, we get Ty as a 2. So these are ties in the series X as 1.5 and ties in the series Y as a 2. And then now we'll use the formula for ranks, Spearman's rank correlation coefficient. So R is equal to 1 minus 6 summation of d square plus dx plus dy upon n square minus 1. So here we just put the values. So d square we have just calculated in a series d square, and this is the total of d square, that is 142.50 plus this is 1.5 tx and this is ty 2. So when we simplify this, we'll get the value as 0.3367. Now, what are the interpretation from this? So when we calculate the correlation, it is 0.35. It is less near to 0, right? Near to 0.5 पेक्षा कमी आहे. So what is our interpretation? It means there is a poor correlation between the scores by M1 and M2. हे दोन्ही match मध्ये M1 and M2 scores आहे. It has a very poor correlation between these 2 matches by the particular cricketer. It is called as a ranks correlation coefficient formula. So in your examination, they may not ask you the such long sum for this. They will just ask you the formula for ties. So for ties in a series, this is your formula. Okay, whether it's a Tx or Ty, X series or Y series, it's the same formula. Here M denotes the length of ties. Okay, and here this formula is for used for the ties. The same formula is for the normal ranks correlation, that is R is equal to 1 minus 6. Okay, 6 summation of D square upon N into bracket N square minus 1. In your book the formula was given wrong, but I have rectified it with the red pen. So you may see the same formula here. And is 1 minus 6 is summation of D square upon N square minus 1 is for without ties formula, and with ties it's the same formula, just you have to add this part Tx plus Ty in your summation of D square. So they may ask you the formula, they may ask you for the calculation of correlations, rank correlation coefficient. So sums will be taken after we complete the chapter, so don't worry about it. Now what is regression? So regression is a technique of prediction on the basis of correlation, is called as regression. That's why this chapter is named as correlation and regression, because regression is based on the basis of correlation. So regression is a line which minimizes the totals of sum of squares of differences between the two values and the values given by straight line is chosen. It means when we draft the bivariate data on a graph with a scatter diagram, there are number of points we got. So with the help of these points, we got the lines. So out of these lines, a line which minimizes the total sum of squares of differences. It means squares of differences will be calculated. Total of such sums of differences is taken, and the line which minimizes such total of sum of squares of differences between two values and value given by straight line is chosen, and the such principle is called as the least square principle. So least square principle is to be used for the selection of the proper line, and the equation so obtained is called as a least square regression line, and the regression line is formed in such format. So how to calculate it without the graph? So for without the graph, we have a regression line. So there are two axes, right? There are one x-axis, this one your x-axis, and this is your y-axis. So there are two lines of regression. One is line y on x, and second is x on y. So what is the difference between these two lines? So here in this case, if the line is y on x, here we assume that y as dependent variable or response variable, and x is an independent variable. It means y's value, it depends on the value of x. When the x changes, y also changes. Because the x reduce, y also have a change in as per the change in x variable. Okay, so this line can be used to predict values of y for known values of x. Because x is independent, that's why the value of x is we know the value of x, and on the basis of x we predict the value of y. So how it is calculated? The formula for this is y minus y bar is equal to b by x into x minus x bar. Now y bar, we already know y bar is equal to summation of y upon n. Okay, and same for x bar. X bar is a mean, that is summation of x upon n. Byx is calculated as covariance of xy upon sdx square. So remember this one, so that Byx is equal to covariance of xy. Covariance xy we have already seen in a covariance in the previous chapter, right? And summation and sdx is already given, so sdx square is to be calculated, and the division of these two will get the Byx, and the Byx value is inserted in the regression line, and we will get the regression line. Now, what is the regression line of x and y? So it's the reverse of y and x. So here x is dependent. Okay, x variable is dependent or response variable, and y is independent variable. It is explanatory or independent variable. And this line can be used to write the value of x for known value of y. It is to be calculated as x minus x bar is equal to bxy into y minus y bar. Here bxy is equal to covariance of xy upon sdy square. So what they will ask in such topics for your MCQ, such as they may ask you the formula for regression line of x on y. So formula will be this one. Okay, or either they will ask the formula for bxy. So bxy is equal to covariance xy upon sgy square. This is a bxy, and for byx is the same formula, that is covariance xy. Just this is divided as a covariance xy x square. This is just the difference between these two lines. And regression line x and y is used to calculate the value of x. You have to remember this, that if you want to find the value of x for given value of y, that time you will use the regression line x on y. And if you want to find out the value of y on the basis of value of x, that time you will use the regression line of y on x. So now correlation and regression. It means if you're calculating such lines and all these, but what is the practical application for this formula, or where it is to be used in a practical life? So this regression lines or correlation regression is used actually in a field of agriculture also. For example, in agriculture, one can use regression lines to estimate change in agricultural production due to various factors such as fertilizers, availability of fertilizers, and irrigation facilities are available or not. What are the fertilities of soils? On the basis of soils fertility, agriculture varies. So it can be calculated through the regression lines, and on that basis, it is to be utilized in the area of where the soil is fertilized soil is different in different areas, and on that basis, the agriculture expert suggests the type of fertilizers to be used for the particular agricultural produce. Then in business and trade, it is to be used such as correlation and regression. Both are helps in planning and forecasting to the data testing, such as portfolio analysis. Index is to be used quite often for businesses, such as index of security. It means how much you have to take a risk, and how much area of the finance is to be secured for the business purpose. It can be calculated through the correlation and regression. It means if there is a large variation between the your security index of security or a regression line, that time you have to use the aggressive measure, so that you can secure your business for a long term. In medical sciences, we can find the regression lines between age of person and blood pressure. You have mainly seen the chart of if you chart of test reports. There is a BP, and they have given the low BP, how many to how many is the variation, and for high BP, what is the variation, and for normal, what is the variation. So these variations can be calculated through the correlation and regression, and it is mostly depends on the age, right? So as per the age, how much your BP should be. So age and your BP ratio, these two variables can be checked through the correlation and regression. Same as growth of a normal baby, or growth of a person is also can be calculated through the correlation and regression lines, such as um, how much age is your, and what will be your weight, what should be your weight as per your age, or as per your height, what will be your weight. It can also be defined through the correlation and regression lines for the medical sciences experiments. Then in economics, it may be interested to know the relationship between age and productivity index. It means whatever productivity rate lies within the industry or within the economy, it affects your GDP, gross domestic product. So for the calculation of this, one person can use this correlation regression lines, such as the age of a person. It means population lies between, suppose, 21 years to 45 age. If the person age is 21 to 45, their efficiency will be also higher, because this is the youngest age which can utilize a more strength in their activity or in industrial area. So on this basis, we can calculate the efficiency rate and what are the area to be expanded in the economics, and what are the job offers to be offered to the public. So all this analysis can be done for the purpose of economics with the help of correlation and regression. Then in finance also, it analyzed with the portfolio analysis. There are two types of risk, that is systematic risk and unsystematic risk. So systematic risk, it means it's a fixed risk which can be occur in any situation, and it is to be calculated with the help of regression line also. And unsystematic risk, it is to be calculated all the time in case of any situation, such as market is down, and suppose due to some situation immediately within a one day market collapse, then that time there is a, it is called as an unsystematic risk. So this risk can be also calculated with the help of your regression lines and correlation, and it will help you to segregate the total risk in systematic and unsystematic manner, so that you can draft a proper portfolio and invest as per the risk level you have calculated. Then in the field of physical education and sports also, it's very helpful because it has a more impact on your analysis, that which game or which sport is more to be flourished, and what is the age group for that particular sport, what is the height to be defined for the particular sports activity. Then what are the aptitude tests for the players, because without the aptitude test, one person cannot, any person cannot be the sportsman. For the sportsman, you need a many aptitudes, such as logical aptitude, then teamwork is needed, group discussion is you needed. So there are n number of aptitude tests which are needed for the sportsman, and this can be conducted through the correlation and regression. So it has a more impact and a more emphasis on a correlation and regression. It will help more in your selection of players. So players selection is just screening month open, right? For the purpose of screening, this correlation and regression is mostly important. Okay. Thank you for today's lecture.